Okay, in part two, we're going to look at some time value of money problems and try to solve some basic questions. Before we get started though, let's look at the spreadsheet. So if you open the spreadsheet, what you'll find is, again, wherever it opens to, but if you look down below, there are different worksheets. In this case, we're going to concentrate on the three worksheets that are right here. One on time value of money, one on the time value loan analysis, and one on the time value for mixed cash flows. So if you click on the time value of money section, here's where we're going to find or be able to solve for different kinds of basic time value questions. If you remember, as we talked earlier, the yellow boxes are the data boxes. That's the information you need to plug in to solve your problems. If the number is not there, right, if you're not talking about payments, then this cell should be blank. The answers and the solutions then are obviously in the light blue boxes to the right. So let's go ahead and solve and work through some problems. So the very first problem is a basic future value question. If you invest $1,000 a year at 10% for 4 years, how much will you have when you are done at the end of 4 years? In the spreadsheet, the present future value is what you're solving for. That's what you want to know. Present value is the investment that you make. It's $1,000. And since we're investing money, it's a negative $1,000. The annual interest rate's 10%, time in years 4, and we're currently using a compounding frequency of just annual times, 1 time per year. So the answer to this problem is $1,464 is what will be in there at the end of 4 years. 4 times 10% of 1,000 is $400. The other $64.10 here comes from the concept of compounding money. That is, interest earns interest over time. What if we change the compounding schedule, right? In this case, we're going to invest $1,000 for 6 years at 12%, but we're going to compound that semi-annually. So all you need to do, enter your data. The difference in compounding, the number of times per year you calculate interest, is placed in this cell that talks about compounding frequency. So P divided by Y is periods per year. I'm not really sure where the letter M comes from, but periods per year certainly is self-descriptive. So 2 times. So at the end of 6 years, if we calculate interest every 6 months, we'd end up having $2,012 odd dollars. And if you look down below, we'll talk about this here in a second or two, you have what's referred to as the effective interest rate. So you actually earn a little bit more money because we compound more frequently than once per year. And that really is the next topic here. The nominal rate, as we mentioned earlier ago, is the stated or the contractual rate. The effective rate is the actual true rate, the APR, the annualized percentage rate. And if you look here for 2 times semi-annually, that's that 12.36% that we saw earlier. If you go out and you change the M to 12 so that we compound monthly, the effective interest rate is 12.68%. And of course, the future value is going to be more because you're earning a higher rate of return. Interest is earning interest more frequently and quicker. What about present value? Let's bring some money back to today so we understand its current value to us. What's the present value of $1,000 if you could receive it in 3 years and you can invest at 13%? Well, you know the future value is $1,000. The present value is what you're solving for. When you solve these problems, again, since the last problem you had a number here in present value, make sure you delete that from the cell. You delete it with the delete key. All right, so make sure you use that. If you end up with answers over here that don't seem to be making any sense, or there are no answers, then you have a number or a variable that has been input incorrectly. 13% at 3 years, this is worth $693.05 in today's money. So that's what you'd be willing to pay today to get $1,000 in 3 years if you could earn 13%. What about payments? Equal cash flows for a certain period of time. Now there's two ways to think about these problems. You can start receiving cash at the end of a period, right? So that's what's referred to as an ordinary cash flow. The Excel formulas, almost all financial calculators are set as a default to assume that cash flows happen at the end of the period. However, if you want cash flows to start at the beginning of the period, you obviously have to change the variables. You have to change how it calculates. So let's think about this problem right here. You start at age 20 and you're going to invest $5,000 a year until you're 60 years old. And let's assume that you can earn 12% on your money. How much will you have at the end of this time frame? So we're going to put in the interest rate. Again, you don't know the future value and you don't know the present value because you're making payments, not a payment today or a lump sum kind of a payment. So in the payment, you put a negative $5,000. Now we're assuming cash flows are happening at the end of a month or at the end of the period. So down here it says, is this an ordinary annuity? And the answer is yes. If this is true, at the end of this 40 years, you would have $3.8 million in the bank. What if you could make monthly payments, right? What if you could make monthly payments all along? All you would need to do is two things. Number one is you have to change the frequency, but then you also need to change the payment. So the payment, 5,000 divided by 12, is $467.67 a month. That total then is $4.9 million. And you'll notice that it's almost $1 million more. As soon as you start making payments, and the sooner you can start compounding interest, the faster and the greater this money is going to grow over time. What would happen, do you think, if we did this on a basis that said we're going to start today rather than at the end? Right? What would we have to do? Well, all you would need to do is change the Y to an N, because now we'd be talking about something called an annuity due instead of an ordinary annuity. And of course, both of these numbers would be larger if you started today rather than waiting to the end of the period. So we've determined that when we get to retirement in 30 years, we need $1.25 million. And we can earn, on average, around 10% a year. What's the monthly payment we need to make to get $1.25 million? So we plug the numbers in, right? 1.25 is what we need in the future. We're trying to solve here for a payment pattern. So there's no present value. Interest rate's 10, time in years 30. And again, I'm asking for monthly payment. So we would need a 12. So we need 12 months in a year. And this is going to be an ordinary annuity. So we would be making these payments starting at the end of this month. The answer is I would like to have, or I need to invest $552 a month for 12 months per year for 30 years, and I'd get $1.25 million. Now also, if I wanted to make a lump sum payment, this fortunately gives us both answers. If you had $63,000 today, you could invest $63,000, and that also would get you $1.25 million compounded monthly for 30 years. Next question. We have this $1.25 million. We've done the right thing. Now I'm at retirement and I need to withdraw this money. The question is, if I assume that I'm going to live for 20 years and I can invest at 10%, how much can I withdraw annually and then monthly? Well, I have $1.25 million, so I'm going to invest that. When I invest that, the annual interest rate's 10% times 20 years. Compound frequency is 1. So in this case, I'd be able to withdraw from this account, I'd be able to withdraw $146,824 a year for the next 20 years after I get to retirement. What would it be if I did it on a monthly basis? I would have to change this I would have to change this compounding frequency from a 1 to 12. In that case, it would turn out to be I could withdraw $12,062 a month for 20 years throughout my retirement time. When you get to retirement, one of the things that we're going to worry about is we're going to worry about inflation. You're going to live for 20, 30 years during retirement, and the only income you're going to have is what you get from Social Security and or whatever you've been able to invest between now and then. So let's say you'd like to retire with $100,000 in income per year. If you were going to live for 35 years and you can earn 8%, how much will you need to acquire in your retirement account? So let's think about this. 8% is the interest rate. You're going to live in retirement for 35 years. Annual compounding is 1. And the payment that I want to receive $100,000 a year. The present value of that is $1.1 million. So when I get to retirement, I need to have $1.1 million in my account, and I'll be able to withdraw $100,000 a year for 35 years at 8% interest. However, I'm a little worried about inflation. What's that $100,000 going to buy in years 20 to 35? It's going to buy something substantially less than what it's going to buy or purchase in year 1. So we have a line item here for growth of an annuity, 4%. We think inflation's going to be 4%. So if inflation's 4%, I need to invest $1.8 million, almost an extra $700,000 of investment, because I want and I'm concerned about how inflation is going to impact my future cash flows. Next, there's a special kind of an annuity called a perpetuity. And a perpetuity essentially involves making a payment today and then receiving a cash flow forever. So let's assume you want to start an endowment that's going to provide your favorite professor, I assume that's me, with $20,000 a year. And the college can earn 10% per year on its investment. How much would you have to donate? Well, the simple formula is you just take the cash flow divided by the interest. You need to invest $200,000. But we have the time value of money worksheet, so let's use the worksheet. Interest rate's 10%. You can't put in time here because it's infinity. Really don't care about the compounding frequency. And you'll notice in this, I just screwed myself up a little bit and I used a different amount. I used $25,000 instead of $20,000. But the answer in this case, the present value of the perpetuity is $250,000. Well, what's 10% of $250,000? It's $25,000. So as long as the college earns 10%, I'll always get my $25,000. What if I wanted the payment to grow with inflation? There's a growth of a perpetuity growth factor here. In that case, I would need to have invested $433,000. Again, that would provide me with $25,000 the first year, and then that amount would grow by 4% per year forever. Now here's a kind of an involved problem that involves a lot of these questions, right? Currently, it's a retirement question. How much did you earn currently? And you earn $50,000. You've been able to save already $15,000. You're going to retire in 35 years at age 60. Inflation's 4%. So how much do you need to earn in retirement, year one, to maintain your current lifestyle? So again, here you see I've given you the variables here, and if you plug these variables and pause the video here, you'll come up with these solutions, right? You need to make $197,304 in year one of retirement. Let's assume you're going to live to be 90, right? And you need to know how much you need in your pension fund to get $197,000 a year from age 60 to 90. So we have what? Time now is 30 years. So again, plug these numbers in and you'll find out that you need $2.2 million. What if you're worried about inflation? In that growth of annuity box, you type in 4.5% for inflation, which means you need $3.5 million. The final question then is, look, if I need $3.5 million when I'm 60 to get this income for the rest of my life, how do I get there? What do I need to invest today to get there? Well, if you remember the above example, we talked about you already have $15,000 invested, and we're going to assume a 12% annual rate of return from now to retirement. How much do you need to get this future value of an annuity? You need to receive $397.99 will get you your retirement income. What I suggest you do is maybe plug in your same numbers. I believe I asked you to do this in an example, but it's something we're going to actually, I think it's good to look at from an investment perspective. Another problem, right? Let's assume that we already have some investing, right? We're already investing, in this case, I need $2 million in the future, right? I currently have $20,000, in your 401k. You're going to retire in 25 years. You've estimated you're going to need this $2 million, right? You're currently investing $250 per month. I apologize, I've screwed this problem up for you, so I'm changing the numbers so that it does make some sense. And your company matches that amount. So I'm investing, that was right before, I'm investing $250, and my company is investing $250. So my total investment is $500 a month. 25 years is how long I have to go. I'm making monthly payments. So the question is, what rate of return do I need to earn on my investments in order to get this future value of an annuity? At this current rate, I need to invest and earn 14.01%. So let's think about that. How likely is it that you can average 14% from now to retirement? One of the things that we'll talk about when we get to some later chapters, and we talk a little bit about this with risk, but the average rate of return in the stock market from what we talked about earlier over the last 32 and a half years has been roughly around 11%. So 14% is going to be pretty hard to beat. So we're going to have to figure out one of two things. Either we need to require less money, which is something we don't want to do, or we're going to have to figure out, well, how much money do I have to invest to get there so that I don't at a certain rate of return. So we could change this question now and say, okay, how much do I need to invest, right, if the annual interest rate is 10%? Then whatever that number is divided by 2, that's how much you would invest, and the other half is what your company would invest. So there's lots of questions that we can ask and answer with these different kinds of problems. As far as solving for returns, right? I bought an asset 5 years ago that cost $50. Now it's worth $75. What's the rate of return on this investment? Future value is 75. It started out at negative 50. That was the investment, 5 years. So I earned 8.45%. So what this essentially means is this is what's referred to as an internal rate of return. It's the rate of return on investment over this particular time frame. So here we have internal rate of return. It's a discount rate. It's the actual rate of return you receive if the cash flows that you're predicting or you think you're going to actually return, or if you're looking at cash flows you've actually received, this would be the actual annualized rate of return on an investment. So what are the assumptions we need to understand? We need to understand interest on interest, how that actually works. Use the internal rate of return assumes that future money, right, these future cash flows are all going to be reinvested at the same rate of return. So again, this reinvestment rate is the rate of return that we're going to earn on future investments. So the question we need to ask is that this is kind of a risk question. Will we be able to receive the same rate of return every year from now till the end of the time horizon, or will it be higher or lower? What's the answer? We don't know. It's in the future. The advantages of the internal rate of return is it uses time value of money. It allows us to look at some comparisons, right? We can use this expected return, the internal rate of return, to determine whether or not an asset is acceptable. The downturn is that it is the calculation itself is complicated if you don't have some type of electronic means to calculate. And fortunately, we have a computer that's going to allow us to do this, right? So the internal rate of return for a stream of income is calculated like this in a spreadsheet. So you need to have the investment is times 0. It's a negative $1,100. And then these are the cash flows that I receive over the next 7 years. So I invested $1,100. I got all of these cash flows. And the last year I got my money back plus another $100. So the interest rate or the discount rate on this time frame was 14%. The number of periods is 7. So the internal rate of return on this money was 9.32%. So is 9.32% enough of a return for us to want to invest in this asset? The discount rate ultimately is something that we'll talk about, is the calculation of what it is we actually want to return. So if you wanted 14, would you buy something that was going to pay you 9.32? Obviously, you wouldn't do that. So the last thing, just to briefly talk, we've talked about this already, is you can use these time value spreadsheets to calculate the rate of growth. This is the change. So you can do it to calculate the change in gross domestic product over 10 years, over the growth rate of dividends over a time frame. So these time value questions are very simply calculated when you have these electronic means to help you. So again, that is the end of part 2 of the risk and return chapter.